Greetings, curious minds. Today we embark on a fascinating journey to the beginning of time. This journey is more than just a trip down memory lane. It's a voyage into the origins of the universe itself, into the very fabric of existence. This is a journey into the heart of time as we know it. Time, that relentless, untamed force that governs all things. It's been a subject of fascination, a muse for philosophers, scientists, and thinkers alike. The Big Bang, the cataclysmic event that birthed our universe, is believed by many to mark the inception of time. This theory, while widely accepted, is still shrouded in mystery, a puzzle waiting to be solved. Our journey today is about demystifying this enigma, about peeling back the layers of the cosmos, to understand where time began. So brace yourself as we delve deeper into the realm of time, back to where it all began. To understand the beginning, we first need to grasp what time is. Time, as we perceive it, is a continuous, unending progression of existence and events that occur in an apparently irreversible sequence from the past, through the present, into the future. It is one of the most fundamental concepts, yet one of the trickiest to define. In physics, time is often intertwined with space, forming a four-dimensional fabric known as space-time. It bends and warps around massive objects, a concept brought to light by Albert Einstein in his theory of relativity. This means that time can speed up or slow down depending on where you are in the universe and how fast you're moving. Intriguing, isn't it? So, how do we measure this elusive entity? Our ancestors started with nature's rhythms, the cycle of day and night, the changing seasons. They carved notches into sticks, let water drip from vessels, and watched the shadow of the sun dial around a circle. These were the first timekeepers, the precursors of our modern clocks. As our understanding of the world evolved, so did our timekeeping devices. Mechanical clocks replaced sundials, and pendulum clocks replaced these. Each advancement brought us closer to the precise measurement of time. But it was the advent of the atomic clock in the 20th century that revolutionized our understanding of time. Atomic clocks, which use the vibrations of atoms to measure seconds, are so accurate that they would be off by less than a second over millions of years. Yet our understanding of time is still evolving. Today's scientists grapple with concepts like quantum entanglement that suggest time might be an illusion, a human construct. And the journey to unravel the mysteries of time continues. Now that we have a basic understanding of time, we can start our journey back to its origin. Let's delve deeper into the past, into the very moment when time, as we know it, began. Let's embark on a journey to the beginning of time. The Big Bang Theory, a widely accepted explanation, suggests time started around 13.8 billion years ago. Now that's a mind-boggling number, isn't it? But let's dig into what this theory really entails. The Big Bang Theory is the prevailing cosmological model of the observable universe, from the earliest known periods through its subsequent large-scale evolution. It paints a picture of a universe that was once incredibly hot and dense, expanding rapidly from a state of immense heat and pressure. As the universe expanded, it cooled, leading to the formation of particles and eventually atoms, which then grouped together to form stars and galaxies. This is the universe as we know it today, a vast expanse of space filled with galaxies, each teeming with billions of stars. But how do we know any of this is true? Well, one of the most compelling pieces of evidence for the Big Bang Theory is something known as cosmic microwave background radiation. This is a faint glow of light that fills the universe, falling into the microwave part of the electromagnetic spectrum, and is believed to be the heat left over from the Big Bang itself. This cosmic background radiation is remarkably uniform across the universe, which is exactly what we would expect if the universe began as an extremely hot, dense point. It's like the afterglow of the Big Bang, a whisper from the very beginning of time. The Big Bang Theory also correctly predicts the abundance of light elements in the universe, such as helium and hydrogen, further bolstering its credibility. However, it's important to remember that while the Big Bang Theory provides a compelling and widely accepted model for the beginning of time, it's not the end of the story. There are still many unanswered questions like what caused the Big Bang itself, and what was there before it. The Big Bang Theory provides an intriguing insight into the birth of time, but let's explore what came before it. What existed before the Big Bang? A question that has puzzled scientists for ages. The Big Bang, the explosive event that birthed our universe, is widely accepted as the start of everything. But what if it wasn't the beginning? What if something or some things existed before that colossal explosion? This is a question that sends us spiraling into the realm of the unknown, where we grapple with theories that push the boundaries of our understanding. One theory suggests that before the Big Bang there was another universe different from ours, but equally vast. This is known as the cyclic universe theory. It proposes that our universe is just the latest in a never-ending cycle of universes, each one born from the death of the last in a Big Bang. The universe expands, contracts, and then explodes into being again, like a cosmic phoenix rising from the ashes of its predecessor. Then there's the concept of quantum gravity effects. Some scientists believe that before the Big Bang, there was a previous phase of our universe, dominated by quantum effects of gravity. In this phase, time as we know it did not exist. Instead, the before was filled with what we now understand as space, but it was subjected to quantum fluctuations. These fluctuations eventually led to the Big Bang, creating a universe with time and the laws of physics as we know them. These theories, while intriguing, are not without their critics. Some argue that they are purely speculative, as we currently lack the technology and means to test them. Others claim that they defy our understanding of the laws of physics. While these theories are fascinating, they are speculative and remind us of the mysteries that still surround the beginning of time. Despite the uncertainties, these theories show us that the universe, and indeed time itself, may be far more complex and fascinating than we ever imagined. Time travel, a popular sci-fi concept, but could it actually be possible to journey back to the beginning of time? This question has intrigued scientists and dreamers alike for centuries. Is there a way to break free from the linear constraints of time? Einstein's theory of relativity proposes that time and space are interconnected in a four-dimensional fabric known as space-time. According to this theory, massive objects such as stars and planets cause space-time to curve, creating what we perceive as gravity. Now, if space-time can be curved, could it also be twisted or folded, creating shortcuts through time and space? This is where the concept of wormholes comes into play. Wormholes, theoretically, are tunnels through space-time, kind of like cosmic shortcuts. Imagine folding a piece of paper in half so that 2 points on the surface are touching. If you could punch a hole through these points, you'd create a shortcut from one side of the paper to the other. This is a simplistic analogy for how a wormhole might work. If such phenomena exist and are stable enough to travel through, they could potentially allow us to journey through time. Furthermore, quantum physics, the science of the very small, introduces its own peculiarities to the mix. Quantum superposition, for instance, suggests that a particle can exist in multiple states simultaneously until observed. Could this principle apply to time as well? Could there be a superposition of times, a quantum soup of past, present, and future all existing simultaneously? These ideas are tantalizing, but it's important to remember that they remain largely theoretical. Time travel, as of now, is not practically feasible. The energy requirements for creating a stable wormhole or achieving quantum superposition on a macroscopic scale are beyond our current capabilities. While time travel remains a theory, it fuels our imagination and our quest to understand the beginning of time. The possibilities are as infinite as the universe itself, and the search for answers continues. Who knows what fascinating discoveries await us in the depths of time? Our journey to the beginning of time takes us through fascinating theories and concepts. It's a journey that begins with the simple yet profound understanding of time. Time, not as we perceive it, but as the cosmic tapestry that weaves the universe together. From there, we delve into the explosive origins of our universe with the Big Bang Theory, a singular event that brought forth everything we see and everything we don't. Yet, what came before it remains one of the greatest mysteries of all. Then we touched on the tantalizing possibility of time travel, a concept that challenges our understanding of reality and opens up a universe of possibilities. These are the milestones on our journey, each one a testament to our insatiable curiosity and our relentless pursuit of knowledge. We may not have all the answers yet, but the journey to the beginning of time continues to be a captivating quest that sparks our curiosity and drives scientific exploration.